Sup Tavarish, I'm gonna show you a bunch of tips and tricks for geometry nodes in Blender 5. Bet you weren't expecting that. Now, a map is usually a grayscale image on your geometry elements. It is often very useful to have those maps in a range from 0 to 1, which is to say normalized. For that, we need to find the minimum and maximum values of our map. We can do that with a field minimum and maximum node. And we can remap those with a map range. The map goes into the value, plug the minimum and maximum into the from sockets, and these two values should be 0 and 1. This will normalize our map. If you want to normalize different sections separately, plug their group ID into this socket. We can easily set a new range for our normalized map using a mix node. Plug the map into the factor, and then this will be the low and high value of the map. To invert a value that is between 0 and 1, we can simply subtract it from 1. This is going to be very useful moving forward. Having our map normalized makes it easy to have a contrast control. We simply use a map range. Now, as we bring these two values closer to 0.5, we get a more contrasty map. To make this easier, we can use a mix node. Set it from 0 to ever so slightly less than 0.5, so 0.499. Then we use our invert subtract node. This goes into the from min and this into the from max. Now we can contrast our map with a simple slider. If our map is normalized, we can also use a power math node to push the values of the map closer to 0 or closer to 1. When you increase the exponent, the values will go closer to 0. To bring them closer to 1, we use two of our invert nodes, before and after the power, and make sure this exponent is always greater than 1. To set hard limits on inputs, we can use a clamp, a minimum or a maximum nodes. To set a lower bound, use a maximum node. To set an upper bound, use a minimum. And to set both, use a clamp node. If your map is in a negative range, you can still use the push-pull effect of the exponent by first passing the map through an absolute node. Then, after the power, multiply it by the sign of the original map, like so. Float curves are not always accurate or easy to set up, so if you want to remap a gradient to something like this, you can use a ping-pong node. At 0.5, we multiply by 2 to restore the value of the range of the map. You can use the power trick to smooth the map. Here we can create more bumps by using an integer node into the multiply. Then we inverse that integer with a divide node. And this goes into the ping pong. We just have to double the integer. And there, we have more bumps. You can quickly smooth up a map using a map range. Just set it to one of the smooth step interpolation options. Random values are great to randomize some setting, but you can also use a noise texture for continuous variations rather than distinct. Use a 1D texture. In the W, you should plug the group's identifier, otherwise you have a single value for the whole geometry. Then just add a float value to this. This will be the seed for the randomness. And with this, we have a much finer control rather than this. To get more random maps, you can separate the color output, and then you have 3 maps. This is more efficient than using 3 noise textures. If you have a noise texture that is mapped to a UV, very often the seam of the UV is very visible, like on this cylinder. In this case, it's the Y gradient of the UV. We can make our noise texture loop around this gradient so that we don't have that seam. Make a copy of the noise texture node. It is crucial that the inputs of both noise textures are the same, so use an input for any settings that you want to change and connect it to both nodes. Now on this second node, use a vector subtract node on the UV map. Identify the coordinate with the seam. In this case, it's the Y, and subtract 1 from it. Then we simply mix these 2 noise textures. And for the factor, we use, in this case, the Y gradient, the one with the seam from the UV. And there we are. We have a looping noise texture. If you've separated your geometry into groups, it is difficult to preview them in the viewport because everything above 0 is white. To see them more clearly, use a 1D white noise texture and plug the group IDs into the W. Then we can preview the groups with the color output of the noise. You can add a value to the group IDs to get different colors. If you want to get the total number of groups that the geometry is separated in, we can use an accumulate field node. Set it to integer and the domain of the groups. Plug the group IDs and the value leave at 1. Now let's use a compare node, integer and equal. We use the trailing output and look where it is equal to 0. Then let's use another accumulate field. The compare goes into the value, then the total will give us the number of groups. Make sure that these 2 domains are the same. If you want to split your groups with a selection, we can use a switch node with that selection. Set it to integer. The group IDs go into the true, and the other half of the selection we set to -1, and we have our groups split. We use -1 because our group IDs, which in this case is the index, are always positive, so there's never going to be a -1 in there. If we want individual groups for the other half of the selection, we can negate our group IDs and plug them in here instead. To make sure that there is no 0 in the group IDs, because -0 is still 0, we simply add 1 to them. To exclude a selection from another selection, we use a boolean subtract node. The one that you want to remove goes into the second input. Node Wrangler is a built-in add-on in Blender that has many useful features. Here are some of them. If you want to swap 2 inputs, like on this mix node, you can use Alt+S. If you want to copy the label from a node to another node, you can use Shift-V. If you have a messy node tree that has a lot of nodes that are not connected to the output, you can clean them up quickly with Alt+X. To remove a node from a frame, you can press Alt+P or simply F. If you have a large node tree, it might be very difficult to connect distant nodes. So here's an easier way. You can shift-click on a socket and it will be selected. You can see that as a slight highlight. Then, in the same way, select another socket from a distant node and you can connect them by pressing J. If we want an integer value to always be even, we can use a modulo from an integer math node, set it to 2. This will give us 0 when the input is even and 1 when the input is odd. Then this result we subtract from the original integer. The output of that will always be even. If you want the output to be odd, simply add 1 to it. To set a general divisibility by an integer, you can set the desired divisor into the modulo. However, this way it will always give us a lower number. Ideally, we want 19 to round to 20 when we set it divisible by 5. So, to make it so it rounds to the nearest divisor, we need to add some more stuff. Bring up another integer for the divisor, then half it by dividing it by 2. Then add this to our input value, like so. And now it rounds correctly. To accommodate for negative values, here we need to subtract instead. We can do that by looking at the sign of the input value and multiply that by the halved divisor. To get the angle between two vectors, first we need to normalize them, then use a dot product between them. The dot product will give us the cosine of the angle between them. To get the angle of the value from it, we run this through an arccosine function. This will give us the angle in radians. If you want it in degrees, use a 2 degrees node. You can only have one menu switch connected to a menu input. If you want to control multiple switches from a single menu, you can set the menu switch to integer, then set the items of the switch to 0, 1, 2, 3, etc. However many you have. Then, with this, use an index switch. You notice Blender even labels the items from the menu switch, and you can have as many index switches as you want. All controlled from one menu. If you want to orient an object in a certain direction, you can use the Align Rotation to Vector node. Simply select the main axis of the object and the direction vector that you want that axis to align to. To further orient these, we can align one of the other axes. For that, we need another Align Rotation to Vector. Select one of the other axes. Set the pivot to whatever the first aligned axis was, and plug the second direction vector. This is how you align two axes. On the surface, you can use vectors as rotations. However, if you need to mix between two rotations, it is better to use a mix rotation node. This has a better interpolation between the two orientations, as opposed to a vector mix. You can control the influence of an effect with a mix node. Plug the effect into the second input. In the first input, set it to something that doesn't affect anything. In this case, since I multiply, I'll set it to 1. If it was additive, I would set it to 0. You can easily get the average between two values by simply mixing them at 0.5. To mix between three values with a single slider, we can use two mix nodes. Plug the first output into the first input of the second node. These will be our three values. For our slider, let's use another mix node from 0 to 2. Plug it into the factors of the two mixed nodes. For the second one, let's subtract 1 from it. Make sure these clump factor options are enabled. And now this slider will mix between the three values. If you want to store a lot of attributes on your geometry, you can combine three float values into a vector and store it as a vector attribute. That way we only store one attribute, which is a bit more efficient. Later, when you want to use the attributes, simply separate that vector attribute and you get your three original values. This could also be used as a color attribute to store 4 values, or with a matrix, which will allow you to store 16 values in a single attribute. However, if you want to use the attributes in a shader, you can only store 3 in a vector. Sadly, there are no matrix data types in shader nodes yet. The accumulate field node is essentially a summation node. It adds the values on the elements of a certain domain. In this case, I add the indices of the points, which we can see here. The leading output starts at the first element and goes down the list, adding the values. 0 plus 1 is 1, plus 2, 3, plus 3, 6, plus 4, 10, etc. The trailing output does the same, but it always starts at 0 on the first element and then adds them from there, like before. The total just gives you the total sum of all values. To get the frame rate of your scene, you can use a scene time node. Simply divide the frames by the seconds, because that's what FPS stands for, frames per second. If you want to use a random value into a socket that only accepts a single value, it won't work. To fix this, plug an integer into the ID of the random value. You can inflate a mesh with a set position node. Plug the normal into the offset and use a scale node to adjust the offset. If a setting is too sensitive, you can multiply it down by some small number to make it more controllable. You can smooth a mesh or a curve with a set position node. Plug the position field into the position input. Then use a blur attribute node. If the object that you're trying to merge is too small, you might end up merging more points that you want to. In that case, use a transform geometry node before the merge by distance, scale it up a lot, like 100 times, then after the merge, scale back down by the same amount to bring it back to the original size. You can preview the points of a curve with a curve to points node. Set it to evaluate it. If the points are too big, use a set point radius node. You can smooth up low poly curves by changing their type with a set spline type node. You can use Catmo-Rom or NURBS. It will make them a bit smoother. The Spline Resolution node is the number of points between the control points of a curve. See, this Bezier curve says it only has 2 points. These are the control points. If we preview its points by the evaluated, it will produce more than 2 points. The number of these is determined by the Spline Resolution. To get the spline type of a curve, you can use the named attribute node and search for the curve type attribute. This will give you 0 for Catmo-Rom, 1 for polycurves, 2 for Bezier, and 3 for NURBS. If you want to redistribute the curve points at even intervals along the curve, first we resample by evaluated, then we resample by count, use a spline length node, and plug the point count into the count. This will redistribute the points of the curve. To maintain the same point density of a curve after a transformation, first we capture attribute on the curve before the transform, use the spline length node, divide the length by the point count, but subtract 1 from the point count. Then we capture this value. After the transformation, we can resample by length and plug our captured value. Now, as the curve is transformed, new points will be added or removed to maintain the same point density. To split a curve into its segments, first we convert it into a mesh. Then we can use the split edges node and then convert back to a curve. Now we have a spline for every segment of the original curve. To make a selection of the boundary edge of a mesh, we can use the edge neighbors node. Boundary edges only have one face connected to them, so let's compare this equal to 1, and this will select only the boundary edges. To create a distance map on our mesh to a selection, we can use the geometry proximity node. Plug the selection into the group ID. For the sample group ID, we need to set it to 1. Then the distance output will give us a distance map to the selection. Points further away from the selection will give us a greater value. You can smooth up this map with a blur attribute node. To smooth only in the middle and keep the corners, use the map itself as the weight for the blur. If we try to smooth this object, it gets smooth in all directions, but I want to keep the height of it and only smooth horizontally. For that, we can separate our position and the blurred position, get the axis I want to keep from the original position and the other two from the blurred position, combine them with a combined XYZ. Now it only smooths horizontally. If you have a large node tree, optimization starts to become important. This node group, for example, gets calculated even though it doesn't do anything. So I can use a switch node and have some condition for it, like this frequency input is greater than 0. If it is equal to 0, this condition will be false, and we will bypass this node altogether, so it is not calculated. That way we can optimize a node tree. Alright, hope this was useful, see you next time.